Today we're going to be talking about ratios and proportions. And a ratio is basically a comparison of two quantities. But we're really going to be writing out this comparison or this ratio as a fraction. So for example, if I want to write the ratio of 16 to 40 as a fraction, you always just take the first number, put that on top, second number goes on the bottom. And then we're going to reduce these fractions. So we have to look for a common factor. Well, I can divide by 4, and that would give me 4 over 10. And then, I could have divided by 8, but I'll divide by 2 now, and that gives me 2/5. So the ratio of 16 to 40 can be written as 2 over 5. Same idea if you have fractions or decimals. The ratio of 2 1/3 to 1 1/6. We take the first number that goes on top, second number goes on bottom. Now we have to simplify this answer. You don't want to leave fractions within fractions. So to simplify, we are going to write each of these fractions as improper fractions. 2 times 3 is 6, plus 1 is 7. So I've got 7/3. 1 times 6 is 6, plus 1 is 7, over 7/6. Now that fraction bar actually means division. This is the same thing as 7/3 divided by 7/6. And we reviewed in the last lesson that if we want to divide fractions, we copy down the first, we change to multiplication, and we flip the second. Then we can multiply straight across, although I notice there's a common factor of 7, and there's a common factor of 3. 3 divided by 3 is 1, 6 divided by 3 is 2, and then I multiply straight across, and I get 2 over 1. Now, in many cases, if you got an answer of 2 over 1, you would just write that as 2. But because this is a ratio, you want to have two numbers because it's a comparison, 2 to 1. And so ratios is the one case where you would just leave the 1 in the denominator like that. Okay, same idea if we have decimals. I can write this as the ratio of 0.5 to 3. But we also need to simplify this one. You don't want to have decimals within fractions. And so the way to do it is I have a digit in the tenths place. And so to clear that decimal, I'm going to multiply by 10. And I have to do that to both the top and the bottom. Multiplying by 10 actually moves the decimal one place to the right. And so that 0.5 becomes a 5. And then 3 times 10 is 30. Or you can think of it as you're moving the decimal one place to the right on both the top and the bottom. So I get 5 over 30. So I clear the decimal. And then I'm going to look for common factors. 5 is my common factor. If I divide the top and the bottom by 5, I get 1 over 6, or the ratio of 1 to 6. So if you have decimals, you have to clear them. Make sure you do the same thing to the top and the bottom. And then you can reduce as normal. Now, a rate really is the same thing as a ratio, except it actually has units. The units are usually different in the denominator and the numerator. So if I want to write the rate, $65 in 4 hours as a fraction, it's the same idea. 65 goes on top, 4 goes on the bottom. And then I would have to reduce if possible. In this case, we can't reduce. There is no common factor. And so you can leave your answer like that, or you could write it as 65/4 dollars per hour. Now, a unit rate or a unit ratio is the same thing, except it's something that has a denominator of 1. And frequently when we're talking about rates, it's actually convenient to express that ratio or rate with a denominator of 1. For example, in the previous problem, if this were an hourly rate, writing that rate as a fraction 65/4 doesn't really make a ton of sense. It might make more sense to actually do that division. 4 goes into 6 once, with a remainder of 2. 4 goes into 25 6 times, with a remainder of 1. And then I could add a decimal and some zeros to keep going. 4 goes into 10 2 times. Notice the decimal doesn't move. Remainder of 2, bring down another 0. and 4 goes into 20 exactly 5 times. So as a unit rate, we could write this as $16.25 per hour. Now the grocery store is one place where unit rates come in handy. Specifically, they're called unit prices. And so let's find the unit price of each bottle of shampoo. The unit price is something that's going to help us compare two different items and see which one is a better buy. So if I've got a 16-ounce bottle of shampoo for $4.68, as a rate, that would be $4.68 over 16 ounces. To write this as a unit rate, I actually have to do that division. So 16 doesn't go into 4, but 16 does go into 46, and I think it only goes in 2 times. 2 times 16 is 32, so I have a remainder of 14. How many times does 16 go into 148? I'm not actually sure for this one. I'm going to make some guesses. Maybe 7 times? 16 times 7 is 112. I think that's too small. Let's try 8. 128. That might still be too small. I'm not doing a good job with my guesses. How about 9? Oh, 9 times 16 is 144. Okay, so it goes in 9 times with a remainder of 4. I'm going to add some zeros and keep going here. 16 goes into 42 times. Remainder is 8. I'll bring down another 0. Oh, finally, 16 goes into 80 exactly 5 times. So for the 16-ounce bottle of shampoo, the unit price is that 29 cents, a little over 29 cents per ounce. Now to do the comparison, we have to do the exact same thing for the other bottle of shampoo. I'm going to take $7.80 and divide that by 24 ounces. So 24 goes into 78. I'm going to guess 3 times. 72, that sounds about right. Remainder of 6, bring down the 0. So 24 goes into 60, I would say 2 times. The remainder of 12, I'm going to add a 0 and bring it down. Oh, 24 goes into 120 exactly 5 times. So the unit price is a little over 32 cents per ounce. And then to finish the problem, based on this information, which one is a better buy? That's the cheaper one, the one with the smaller unit price. So the 16-ounce bottle of shampoo is the better buy here.